Hello, my name is Claudia Benito Alston, and I will be presenting on the design and porosity tuning of a 2D printed mandibular bone graft. Critical size defect maxillofacial reconstruction can be necessary for a myriad of reasons, the simplest being tooth loss leading to bone loss. We designed a cover and core concept to improve osteointegration by modeling a 3D printed core with a protective cover. The goal of this model was to elucidate which cover design and fixation method would prove to be the most ideal for sustaining mastication, limiting stress shielding, and ideally allowing cell influx due to porosity. First, we created 6 different models: a solid model with no screws, a faulty model, both 1 millimeter and 0.5 millimeter porous cover models, and then a solid reinforced with screws on both sides model. The mod stress demonstrated that none of the materials would yield since all the values were below the yield strength of the materials themselves. The highest maximum stress was found on the porous cover in the 0.5 millimeter porous cover at 14.17 megapascals. The von Mises stress distribution on the 1 millimeter porous cover showed that the highest stress propagated down through the screws, most likely through the cover. We demonstrated that for the considered materials, a porous cover core design sustained mastication without yielding while providing the least stress shielding and allowing diffusion of biological factors. Using an open source file, we imported the mandible into Meshmixer, where we designed the graft. It was then imported into Ansys, where we modeled vertical compression at the maximum mastication force of a healthy adult, which was 500 newtons. Then we fixed the bottom edge of the mandible to recreate mechanical testing methods. And lastly, the material properties were added to the model, leading us to the finite element analysis being performed. The clinical implications are that the current standard of care make use of bone particulates that are packed into a defect, then covered with a titanium mesh and fixed in place with titanium screws. This leads to unreproducible packing or porosities. The benefit of 3D printed bone graft are a shorter surgery, which is important since ORs cost around $70 per minute, reproducible porosity, and a protective cover design allowing for maximum cell infiltration and limited stress shielding. Lastly, all the materials are completely resorbable and fully integratable. Thank you.